They depends on all these open source packages, and most of the time, people that created them, they don't maintain them. So sometimes tools that those dependencies also depends on becomes vulnerable to some sort of malicious code and or outdated codes and dependencies, and it in turn affects yours. So that's why this tool we are going to build is important. Uh, so um, so we have to look at the problems first, like the current reality. So we are looking at it from the problem standpoint. Then, if we understand the problem, we provide a solution, and then we go into building the solution. So let's say a current reality, you inherit a project with 50 plus dependencies. Some of them have been never been updated, like in 2 years. You have no idea if they have security issues, and you can't go and be checking them one by one. Maybe copy the name, go to Go modules and check and all that to know whether this is the latest version or I know that there are extensions, tools that you can plug into your code editor that will help you to do that. But what if you did your own, right? So, and then our solution is that we need a command, something that will run and it will check all these things in seconds, tells us, okay, this is an old version, but you can still use it, or this is an old version, it has vulnerability. You have to bump to a newer version or something like that. And it also gives us like a general health score of packages or dependencies in our projects. So, for example, there's this Equifax breach that cost about 153 million. Um, people being affected because an outdated dependencies were used, and it affected a lot of people, right? So these are like problems. And why did we choose to, use Golang for this? So because number one, distribution. So if you use other languages, you have to, you know, think of dependencies, think of packaging, think of how you can make it run everywhere. But with Golang, once you just build it, you can run the binary everywhere. You can run it command line, you can run it in your pipeline, you can run it anywhere, any operating system, right? And it's the speed, of course, and also cross-platform, like I said, and then handling parallel tasks. So you just run the simple function. It goes concurrency, which we'll talk about later. You don't have to think about thread, synchronous operation, and all that. Then let's talk about the anatomy of a good CLI tool. So these are like the things I look out for when okay, I want to build a command line tool, right? So first of all, how fast is it? So nobody wants to wait. I type a command, I have to wait for like 100 hours, 1 hour, in fact 10 minutes. I've not seen like an output or something. So people don't want that, right? Then it should be clear. So um, the messages should be clear. So if I'm getting an error, I should know this is an error, right? If I'm getting a warning, I should know this is a warning. If it's a success, I should know this is a success message, right? Then it should be actionable. So you don't just report problem. Okay, you have 100 dependencies that are outdated. How can they fix it, right? So you also like explain, or you also have like helper flags, command that they can run and bump up those versions. And then flexibility. So, human beings, they like to understand the colors, emojis, then things like machines. If you're running it on pipeline, it wants JSON. So it must be flexible. Um, that's why you have, when you run some command line, you pass a flag. Okay, I want this to be verbose. I want this in JSON. You pass the flag. It gives you. I want to run this in a particular file or a particular folder. You pass the file part, right? It has to be flexible. So you can see from here. So this is like a batch CLI, just error message. But this one gives you like a message and what to do to update them. So for what you are trying to build. These are the core features. So to check the version, to scan for security and vulnerabilities, to check the license to know if your business should use this package or not. Is it open source? Is it a paid software? Is it do you have to sign some kind of agreement for it and all? Then also check like the age analysis, the last time it was updated and all. Then so we need to understand some certain things before using Go to build command line, applications, right? Like I said, I'm a beginner, and if you're a beginner, you also like need to understand some certain things like seeing the code in the demo, right? So talk about modules. So what are modules in Go? So you see an example of how to define modules in Go, right? So your first one say module a part to a GitHub project, right? So let's say that part is a package that you want to use in your application. And the second line tells us the version of Go that you want to run. Then the line 6 to line 9 tells us the um, external folder packages that you're using, right? So, and then they also like have their versions attached to them. So if, for example, your project is a cake, so this is like an illustration I use. So Go modules lists like the ingredients, like the flour, the sugar, the eggs that it's expected or that you use to do the cake, coupled with their expiry dates or the manufacturing date. So with that, you will know are they expired, are they still good and hot, right? So that's clear understanding of Go modules. Then things we'll be utilizing while building our package is something called concurrency. So like the name say, concurrency, doing multiple things at the same time, as opposing to doing them one after the other. So say I want to check out, I have like 50 packages, right? I want to check their versions. I want to see if this one has vulnerability, if this one, if they are outdated and all. So without concurrence, I'm checking them like one after the other. Let's say each one takes like 2 minutes. So that block of code take like 2 seconds, to run. So it will be running them 2 seconds each. That's 100 seconds to that time. But with Go concurrency, I do all of them in 2 seconds because I have to use that Go feature of running those tasks in parallel instead of running them one after the other, right? So that's like the layman's explanation of concurrency. So unlike languages like JavaScript, TypeScript, Golang actually like makes use of your machine's memory. You have 8 GB to make use of them, it utilizes it. Unlike JavaScript that maybe just that portion, that memory that's allocated to it that it will make use of, right? So it has to make sure that maybe it runs those programs to make sure that it doesn't exceed those memory, right? But Go will make sure that as far as there's enough memory, it can concurrently run tasks and maximize those memories. Then some of the key patterns that we're going to see in this CLI tool, the error check pattern. So why it matters is because Golang forces you to think about what could go wrong, at every step. Just like having a rail guard on the mountain. When you're building CLI tools, like I said earlier, you think about the developer's experience, you think about people that are using it, how they will really use it. So you don't want to say an error occurred. You don't just want to say, oh, something happened, right? You need to be like specific. So error occurred. This is also part. This is the error message. Permission denied, right? This is the error message. You don't have the system requirements. Just state it out, right? So these are some examples of bad error message, and the other one, these are some examples of good error message. They tell the users what happened and what they can do. Then how this CLI is going to work. So you type go flush, and it's you go to your go.mod file, read out the dependencies. It spawns workers to check them simultaneously, check the version, security license, combine the results, calculate the health score, and show you like beautiful and actionable results. Very simple. Then see what like a successful run looks like, something like this. So yeah, so let's do a little bit of demo. Sorry. Okay. I will have to include this. Perfect. Sorry. Okay. Okay. So this is the file we'll be using. Everything is inside this code base, right? Inside this one file. So we'll be using these tools here. So these ones are from standard library from Golang, and these one are like external. So this one is for printing out colored files in the terminal, and this one is for to pass and format GUMOD files. So we'll be reading vulnerabilities from this endpoint, and then so maximum concurrent check 5. So this one helps us to calculate the scores, the excellent threshold, the poor threshold 70, and vulnerability penalty, outdated penalty. Then for license, we don't know what they are, we just say unknown. So we define these structs to, we are not using like any external database or something within in-memory. So we define structs for dependency, for configuration. So this configuration is options you can pass or flags you can pass to the command, like a path, like the severity, like if you want a JSON output, if you want the command to fail once it catches a vulnerability, right? Or if you want like a verbose response. So for JSON output, this is like the type, right? Then for the request of for vulnerability, this is like the type we're using, and these are the types. So I want us to go straight to the so the main function. So so here we'll pass the flag. Any flag is passed to the command. We'll validate the configuration, and then we check the dependency, pass the GoMod file with the configuration that was passed, and then we print, okay, we're scanning as so far part if it was passed. And then if it is not JSON output, that means we want to print it in the command line. Okay, you mentioned the number of dependency found, and this is like the function that actually analyzes dependencies, and then you print it on the command line. Yeah. So, and after that, if the configuration or the flag pass say fail vulnerability. So once you catch any vulnerability, if it has vulnerability, right, it displays the result. So if you say fail on vulnerability, you exit the command. Simple as that. So now these are like so all these helper functions we use here. So these are like the code. So this one is to pass whatever flag that was, passed to the command line. And so if it is verbose, if it is fail when you find the vulnerability, if it's the severity, right? If you want to search for only low-level vulnerabilities, medium, high, sorry. If you want to run the command on just a particular path, not the maybe root, Maybe you want to run it in a particular path, right? Then what again? Um, so okay, this one validates the configuration to make sure that it's the right type. This one is to print the header using the color package, and this one passes the Go module files, and this is to handle the error. So this is the error pattern we mentioned earlier, and yep. So when we pass an error, so when we catch an error, we use this one to handle the error. So as and we use the correlate to print it accordingly. So yeah. Then so hold on. Okay, yeah. So this one passes the Go module file. Okay, I think this this is this here. So you used to pass the Go module file. So you read the file go.mode here. Then it checks the dependency, the path, the version, and all. Then this one analyzes them. So so this is where we spin up the worker, and then we run the analyze single dependency function per each worker. So we're using like a range. So for a range, I think we set 5 as a range. So it will be running them kind of in batches. Then, so this is the analyze single dependency. So it will call, sorry, okay. It will get the latest version. Okay, this is, sorry. Okay, yeah. This one gets the latest version of the package. This one gets update on severity if there are any. Then this one calls the API that I showed you earlier to make sure if there are vulnerabilities or not. Then this one detects the license. So these are like the helper functions for them. So this one gets the latest version. This one checks the vulnerability, calls this OSV third party, right? Then it gets the response here. Right, then this one gets the update on severity. So based on the response, okay. So based on the response, it categorizes them under major, minor, or patch, right? Then this one detects the license, whether it's what they call it again, MIT, IXC, and likes. Then yeah, and this one displays the results. So I don't have time to go into the code, but yeah. So let's do like a quick example. So I have a reading here. So I've already like built it, which is this build file here. So I can run it with this command. This command here. So I'm running it on the root file, which is this project itself. So it's checking for dependency here. So on this root file, it says that these are Go correlable, Go Isati, and this one. So it checks all of them and says no vulnerabilities. So I have this test data here. I have this test data here that has the modules with some vulnerability, like 3 of them. So I'm going to run it on that part. So so here I'll pass the path flag, right? So I'll pass the path flag. Sorry. I'll pass the path flag here, and I'll say test data / vulnerability. Vulnerable project. Okay. Sorry. Vulnerable projects. Sorry. Okay. So it says it found three dependencies, right? So it's checking them. Um, yeah. So it found two security issues. So it said for this JWT Go that it has a vulnerability, this CV 2020-6160, and say upgrade to the latest version. The second one, we say it has this security version vulnerability too, upgrade to the latest version. Then it also found outdated packages and showed us the version we should come to, and then some license summary here as well, and then the health score. And it also tells you the action you have to take. So this is the demo. Yeah. So back to summarize the yeah. So this is how we can use the CLM tool. So you can install it in your project. You can run it in a Docker container. You can install it using Homebrew on your laptop globally. And you can also run it using code. You can also run it in a CI/CD pipeline as well. And some of so you can see some other information on how to build it on these recommendations here. And thank you very much for your time. If you have any questions, I'm